This is another topic under analysis and synthesis of television pictures. This topic is about number of scanning lines. Most scenes have brightness gradations in the vertical direction. Gradations meaning that is a series of successive changes. The ability of the scanning beam to allow reproduction of electrical signals according to these variations and the capability of the human eye to resolve this distinctly while viewing the reproduced picture depends on the total number of lines employed for scanning. It is possible to arrive at some estimates of the number of lines necessary by considering the bar pattern where alternate lines are black and white. If the thickness of the scanning beam is equal to the width of each white and black bar and the number of scanning lines is chosen equal to the number of bars, the electrical information corresponding to the brightness of each bar will be correctly reproduced during the scanning process. Obviously, the greater number of lines into which the picture is divided in the vertical plane, the better will be the resolution. However, the total number of lines that need be employed is limited by the resolving capability of the human eye at the minimum viewing distance. This is the scanning spot perfectly aligned with black and white lights. This is the beam path, the dark, then the beam spot is the white. We have dark white, dark white, dark white, dark white. So the beam path thus includes the dark, while the beam spot includes the white. Then this is the viewing distance as determined by the ability of the eye to resolve two separate picture elements. This is the adjacent black picture, and this is the eye of the observer. Then again, this is the scanning beam that is focused in the junction of black and white lines. This is the beam path and the beam spot, and this is the dark, then the white. Those are the black and white adjacent resolution. Those are the adjacent black and white lines of resolutions. The total number of scanning lines is chosen close to 860, and the scanning beam as just passes over each bar separately while scanning all the lines top to bottom of the picture frame. A distinct pickup of the picture's information results, and this is the best that can be expected from the system. This perhaps explains the use of 819 lines in the original French television system. In practice, however, the picture elements are not arranged as equally spaced segments but have a random distribution of black, gray, and white depending on the nature of the picture details or the scene under consideration. Statistical analysis and subjective tests carried out to determine the average number of effective lines suggests that about 70% of the total lines or segment get separately scanned in the vertical direction, and the remaining 30% get merged with other elements due to the beam spot falling equally on the two consecutive lines. However, there are other factors which also influence the choice of total number of lines in a TV system. Tests conducted with many observers have shown that though the eye can detect the effective sharpness provided by about 800 scanning lines, but the improvement is not very significant with line numbers greater than 500 while viewing pictures having motion. Also, the channel bandwidth increases with increase in number of lines, and this not only adds to the cost of the system but also reduces the number of television channels that can be provided in a given VHF or UHF transmission band. VHF refers to very high frequency with the designation range of radio frequency from 30 to 300 MHz. UHF refers to ultra high frequency with the designation radio frequencies range between 300 MHz and 3 GHz. Thus, as a compromise between quality and cost, the total number of lines inclusive of those lost during vertical retrace has been chosen to be 625 in the 625-B monochrome TV system. In the 525-line American system, the total number of lines has been fixed at 525 because of a somewhat higher scanning rate included in this system. That's all, and God bless.